S. Chan presents educational video lectures as per the new UGC CBCS curriculum. Absolutely free. Difficult science concepts made easy. Study anywhere, anytime.
Hello everyone, my name is Manika and we are here to discuss the topic aldehydes and ketones. And in this video we will be continuing with our previous discussions with elaborate reactions, much more from the previous ones. Welcome to the channel S. Chand Academy. With more info on this topic, refer to our book by S. Chand Publishing and the link for which is given in the description box below. Let's start with today's topic. In the previous video, we have looked at how aldehydes and ketones behave under the presence of a nucleophile. They undergo nucleophilic addition reactions because the carbonyl group is electropositive, and in the presence of nucleophile, it attacks the carbonyl carbon easily, and thereby we get the nucleophilic atoms. In this lecture, we will focus a bit more on the other properties which aldehydes and ketones undergo or they behave. If you look at the structure of a carbonyl compound, say acetone or say propanol, if you look at the hydrogen atoms which are near to the carbonyl carbon, what is special about them? These hydrogen atoms which are attached to the carbon, which is directly linked to the carbonyl carbon, are known as alpha hydrogen atoms, and the hydrogens on the next are beta hydrogen atoms. So why I am focusing the alpha hydrogen atoms over here? Because the next set of the reactions which I am going to discuss will be linked to the reactions of or the behavior of these hydrogen atoms. Alpha hydrogen atoms have a special property in case of carbonyl compounds. And what is that? Let's look at it. Under the influence of the base, these alpha hydrogen atoms can be easily abstracted. And once this hydrogen atom, alpha hydrogen atom, has been abstracted, we get a stabilized carbon ion. इस stabilized carbon ion को हम कहते हैं enolate ion. Enolate ion is resonance stabilized, as you can see in the structures over here below. And since there is a negative charge on the carbon, now this carbon is nucleophilic, and it is this nucleophilicity of this carbon atom and it being stabilized due to the presence of the carbonyl group, this can be used as a reagent to attack another carbonyl compound. So based on this chemistry, we will look at the further. Let's look at the structure over here. This is a simple ketone, and the alpha hydrogens over here are acidic. And after the removal of hydrogen atoms, the structure, the intermediate which is formed is enolate ion, and the enolate ions are resonance stabilized. So the first reaction in this category is aldol condensation. This is a very common reaction. You must have heard it elsewhere also, and let's look at what is the reaction. Aldol condensation. Under the influence of a mild base or acid, 2 moles of an aldehyde or a ketone or an aldehyde or ketone amongst themselves, they can undergo condensation. Condensation matlab 1 plus 1, दोनों combine होके they can condense to give a molecule of aldol. एल्डोल का मतलब क्या होता है? बीटा हाइड्रोक्सी एल्डिहाइड या बीटा हाइड्रोक्सी कीटोन. Because why aldol? Because it contains both aldehyde group and the hydroxy group. Alright. Suppose two molecules of acetaldehyde undergo condensation. So what will be the product? The product will be 3-hydroxybutanol. And beta position पे क्या है? यहाँ पे hydroxy है और carbonyl group is there. So carbonyl group से beta position पे आपका hydroxy group आ जाएगा. And if you heat it, then the dehydration will happen and you will get an alpha beta unsaturated carbonyl compound. So aldol condensation are very important reaction in a way that they give rise to another class of organic compound which are aldols or alpha beta unsaturated carbonyl compounds. So there are two ways in which you can carry out aldol condensation, either by acid catalyzed or by using the base catalyst. Usually aldol condensation is base catalyzed. So let's look at the mechanism of this reaction. Suppose you have an aldehyde, say CH3CHO, in the presence of the base, the alpha hydrogen will be abstracted and you will get a carbon ion which will be resonance stabilized. I am not drawing the resonance draining structure again because I have just drawn it just a minute ago. So now this a carbon ion which is nucleophilic will attack the second aldehyde molecule. So the product is beta hydroxyaldehyde. Alright. So whenever the aldol condensation takes place between the two aldehydes, the requisite condition is that your reactant should have alpha hydrogen atoms. अगर आपका compound, say for example, is this type of the compound will not give any product under the conditions of aldol condensation. Why? Because there is no alpha hydrogen. So the requisite condition or the primary condition for aldol condensation to take place is that your compound must have alpha hydrogen atom. It is this alpha hydrogen which will be abstracted under the presence of a mild base, which will give you the corresponding enolate, and enolate will attack another carbonyl compound to give you the alpha hydroxy beta hydroxyaldehyde or ketone. If this reaction is acid catalyzed, as we discussed in the other nucleophilic addition reactions also, the first step will be the protonation of one carbonyl compound and the second step will be the enol formation of the second carbonyl compound. So the protonated form of the first carbonyl compound will be attacked by the enol form of the second carbonyl group to give you the condensation product. In the acid catalyzed mechanism, the products are alpha beta unsaturated aldehydes or ketones. Let's look at the sum of the aldol condensation for the synthesis of aldol condensation methods for the synthesis of few of the organic compounds. Suppose we want to carry out, the question says carry out the aldol condensation between two molecules of propanol. So propanol is CH3, CH2, CHO. So what are the alpha hydrogens over here? There are two alpha hydrogens over here. So under the conditions of mild base, dilute NaOH or dilute KOH, what will be the product? The product will be CH3, CHOH, CH3. So this will be the product. You can see one of the alpha hydrogen will be eliminated and it will attack the second propanol molecule and the product will be corresponding beta hydroxyaldehyde. So it's very important to look at which particular carbon is going to lose the alpha hydrogen. In case two similar aldehydes are there, it's very easy. But for example, if we have benzaldehyde and acetone, again It's very easy. One of them is benzaldehyde, it has no alpha hydrogen atoms. The other one is acetone. Acetone has alpha hydrogen atom, both of them are same. So any one set of them can lose an alpha hydrogen and you can get the corresponding product. Another example which I can mention over here is a reaction between acetone and butane 2-one. Whenever we have reagents like this, acetone and now here in this reaction you can see that there are two types of ketones. So what is expected? So this is basically called a cross aldol condensation. जब भी aldol condensation दो different reactant molecules के बीच में होता है, हम उसे कहते हैं cross aldol condensation. So here one of them is a ketone molecule, another is also a ketone molecule. So you can get basically 4 sets of the products. One is by condensation between two acetone, two propanone can undergo condensation, and acetone and propanone can also. So basically 3 types of the condensation products are possible, but what will be predominant? The predominant thing will be the one that is the ketone which has the CH2 group adjacent to the carbonyl group. It is this CH2 which will lose the alpha hydrogen. Why? Because the ketones are poor nucleophile acceptor, but they are poor electrophile acceptors, but good nucleophile sites they can provide. So it is this carbon which will tend to lose the alpha hydrogen and it will attack the acetone. So this will be the product, the major product of this reaction. Okay, so this will be the most stable carbon ions, because if this will form the carbon ion, you can see the enolate is more stable as compared to if the terminal CH3 will lose the alpha hydrogen. So this will be the major product. So you must be able to mention which will be the major product in this reaction. Another important set of the reaction given by the aldehydes and ketones is Cannizaro reaction. Cannizaro reaction is a reaction which takes place when two aldehydes which have no alpha hydrogen atoms, they undergo condensation in the presence of a concentrated base. I am mentioning this very clearly that the basic difference between aldol and Cannizaro reaction is the concentration of the base. While aldol takes place in the presence of a mild base, dilute base, Cannizaro reaction takes place in the presence of a strong base. Basically 50% solution of aqueous or ethanolic base is required to carry out Cannizaro reaction. So aldehydes that have no alpha hydrogen atom undergoes Cannizaro reaction to give the corresponding product. So what are the products in the Cannizaro reaction? Suppose two molecules of aldehydes which are devoid of any alpha hydrogen undergo Cannizaro reaction in the presence of a strong base. Say for example, if I take HCHO, which is formaldehyde, in the presence of a strong base, then the products will be sodium. 1 mole of your aldehyde will form the alcohol and the other one will form carboxylic acid. So these are the two products of the Cannizaro reaction. So Cannizaro reaction is an important reaction to synthesize such compounds. I'll briefly explain the mechanism of the Cannizaro reaction also. So the first step in this reaction is, let's take up this reaction with this only. So as you can see the mechanism of this reaction, the first step, the aldehyde molecule is attacked by the base, and the first mole of the aldehyde which has been attacked by the base, now in this from this compound, it is the hydride which acts as a nucleophile to the second aldehyde molecule, and the product of this reaction is a carboxylic acid and an alkoxide ion. Alkoxide being a strong base will withdraw the proton from the carboxylic acid, and the actual products of this reaction will be salt of the carboxylic acid and an alcohol molecule. So these are the two products which are formed in any Cannizaro reaction, that the one of the mole forms the sodium salt of the carboxylic acid while other forms the alcohol. I am again mentioning why not alkoxide and the carboxylic acid, because alkoxides are stronger base, they will abstract the proton from the carboxylic acid to give you the corresponding alcohol and the carboxylic acid. So it's time for a break now. So before leaving you for a break, I'll put up a question for you. Say, predict the condensation product which you will get when you will use acetaldehyde in the presence of dilute NaOH. I am again repeating, condense 2 moles of aldehydes in the presence of dilute base, dilute NaOH.
हेलो एवरीवन, आई एम डॉक्टर सचिन कुमार और मैं आ रहा हूं एस चांद एकेडमी पे बीएससी फिजिक्स के बहुत सारे टॉपिक्स लेकर, सिर्फ आपके लिए। बेल आइकन ज़रूर प्रेस कीजिए सब्सक्रिप्शन के साथ, ताकि हम जुड़े रहें और आपको ऐसे टॉपिक्स कराते रहें।
Welcome to S. Chand Academy. I hope you are liking the lecture, and to get more into such videos, please log into our channel. So getting back to the question which I just gave up, acetaldehyde has a molecule which has alpha hydrogen atom, so it will easily lose the alpha hydrogen, and as I mentioned, dilute base, so it will attack the another aldehyde molecule, acetaldehyde molecule, to give you the corresponding beta hydroxyaldehyde. It's as simple as that. One more important point over here is that Cannizaro reaction can be intramolecular as well as the intermolecular also, just like the aldol condensation. So whenever a mixture of aldehyde is there where we have two different types of aldehydes, one is an aldehyde without an alpha hydrogen and the other one is also without an alpha hydrogen atom, then the condensation will be called as cross Cannizaro reaction, just like I discussed crossed aldol condensation. So for example, if you have benzaldehyde reacting with formaldehyde, so which one you think will form the alcohol and which one will you think will form the salt of the carboxylic acid? It is formaldehyde which will form the salt of the carboxylic acid. Why? Because the carbon of formaldehyde is more electropositive as compared to the carbon of benzaldehyde, because it has a phenyl link attached to it, or a phenyl ring attached to it. So formaldehyde will give you the salt of the formic acid and benzaldehyde will form benzyl alcohol. Another important molecule which I want to mention over here is intramolecular Cannizaro condensation reaction. So when a mixture of aldehyde reacts with another aldehyde, both without alpha hydrogen atom, the reaction will be cross Cannizaro reaction. So I'll just give you an example to brush it up. Suppose, okay, so if you have a molecule which has two aldehydes linked to the benzene ring, so the product of this reaction will be, one of them will be converting to carboxylate and the other one will be an alcoholic group, right? Moving further with the reaction, like considering the acidic character of alpha hydrogen atoms, one of them is Ideoform reaction. Ideoform reaction basically is linked to a test which we do in the laboratories to check for the presence of methyl ketones. Methyl ketones क्या होते हैं? Which have a CH3 group, a methyl group directly linked to a carbonyl group. So whenever we have such a group in our organic compound, it will be named as methyl ketones. Not only methyl ketones but also alcohols with the structure like R, CH, OH, CH3. Such a type of molecules also gives positive iodoform reaction, and it is known as iodoform test. So what is iodoform reaction? Iodoform reaction is when a ketone which is having the alpha hydrogen atom, specifically methyl ketone, it reacts with the halogen in the presence of the base. So what will base do? Base will abstract the alpha hydrogen unless and until all of them have been substituted by the halide group. And once all of them have been substituted by the halide group, then it will just under the presence of the base, it will act as a leaving group. So CH3 minus will be a leaving group over here. So the leaving group minus group will be this trihalide. This will be the leaving group, and the product will be again a sodium salt or a carboxylate, whatever base you have used. Along with that, CHX3, and if you do the iodoform, CHI3 is precipitated out as a yellow PPT in this reaction. So it's an important reaction to explain two things: one, acidic character of alpha hydrogens in the carbonyl compounds, and second, to test for the presence of methyl ketones. Now the next reaction which is crucial to aldehydes and ketone chemistry is benzoin condensation. As the name suggests, condensation. जब भी मैं condensation की बात कर रही हूँ, that means I am talking about reaction between two molecules. So coupling reaction between two aromatic aldehydes in the presence of KCN, alcoholic KCN. I'm saying alcoholic, that means no water. Alcoholic KCN that allows us to give the preparation of alpha hydroxy ketones, yani ki benzoin. So the benzoin is formed when benzaldehyde is reacted in the presence of KCN, alcoholic KCN, the product is formed. Now this benzoin has a typical mechanism for its formation. So the first step of this reaction is the first mole of the benzaldehyde in the presence of cyanide as a nucleophile right. This will attack in a usual nucleophilic addition way, and then this will undergo intramolecular proton abstraction to give a carbanion, and now this carbanion will attack a second molecule of benzaldehyde in such a way that the product is and then the cyanide will leave to give the corresponding benzoin. So this is the product of this reaction. So as you can see on the screen over here also, cyanide being a good nucleophile can stabilize the intermediate ion and is an excellent leaving group. So now look at the last leg of the properties of aldehydes and ketones, which is the reduction reaction. When we were discussing the chemistry, I already mentioned that when we tend to react the aldehydes and ketone with sodium borohydride or lithium aluminium hydride, the products are alcohols. But if we want to reduce the carbonyl group, that is, we want to carry out the deoxygenation of aldehydes and ketones, what is the reagent we will use? The reagent which we use over there in this case are Clementine reduction, that is, the reactions are known as Clementine reduction and the Wolff-Kishner reduction. These are the two basic set of the reaction. In the Clementine reduction, we use zinc amalgam in the presence of HCl followed by hydrolysis to give you the corresponding alkyl substituted compound if you have the phenyl group in the ring. And in the Wolff-Kishner reduction we use hydrazine. The first step is the formation of hydrazine by reacting carbonyl compound with the hydrazine to form the hydrazone, and the second step is hydrolysis of this hydrazine in the presence of the KOH and heating it to give you the corresponding reduction compound, that is a deoxygenated compound, that is alkyl substituted compound. So the Clementine reduction is basically useful for those compounds also which are not sensitive to acid. Okay, and Wolff-Kishner reduction is also a similar reaction of this kind. And the last reaction is Mirvin-Ponderosa-Verlais reduction. This is opposite of Openier oxidation. This reaction is used for the reduction of those carbonyl compounds which have an olefinic group present in the molecule, and if this olefinic group is there, then to keep it unaffected we use aluminium isopropoxide in the presence of isopropyl alcohol to give the corresponding olefinic alcohol. So this is the product of this reaction. So this is exclusive reagent to convert an carbonyl group into the alcoholic group, keeping the olefinic group intact. With this we come to an end of the topic of properties of aldehydes and ketones. I hope you like the discussion over here. For more such videos, please log on to our channel on S. Chand Academy, and for more info about this topic, please refer to our book by S. Chand Publishing, the link for which is given in the description box below. I hope you like the video. Please have a good time. Thank you.